Hello and welcome to the video on reading and writing function notation, substituting numbers and expressions into functions. So, you may be wondering, well, what is a function? And before I tell you what a function is, I'm going to write the equation y is equal to 2x plus 3. So we know this as an equation. So if we want the value for y at a point, we substitute a value for x, and then we get that value of y. So for example, we could say, what is the value of y when x is equal to 2? So we'd substitute 2 into this, so we're left with 2 times 2, which is 4, and that's then plus 3. So when 2 is substituted in, y is equal to 7. But what are we really doing there? So you may remember from when you very first learnt some algebra, the function machine. So I'm going to put function machine. And what is a function machine? Well, we input something into our machine. So there's an input. And then we get an output. So in our example here for y is equal to 2x plus 3, we've inputted x is equal to 2. It's gone through some sort of operation in our function machine, and we've got the value of 7 out. So we put the value of 2 in, and then you can see we times 2. So we times 2, then we add 3 to that value, and then we get our output, and our output was 7. So this is called a function machine. However, there is a slightly different mathematical way that we can write functions where we don't need this big diagram, and that will be the next part of the video. So rather than drawing the big function machine diagram, what we can do instead is we can write something like this. So f of x. And what that means is a function of x. So our function of x in this case is 2x plus 3. Well, what does function of x mean? Well, if you look at the right hand side of our equation, we've got 2x plus 3. So the letter or the variable is x. So it means that we can change x and get different values out. So like before, where we said, well, x is equal to 2, we can write that slightly differently with our new notation. We can write f of 2. So that f bracket 2 reads f of 2. So like before, where we saw x was appearing here. So if we put 2 in, then the 2's got to take the place of the x. So we get 2 times 2 plus 3. 2 times 2 is obviously 4, plus 3 is 7. So f of 2 is equal to 7. So that saves us having to write our big diagram, because now we've just got the function at the value of 2 is equal to this. So I'll write on the last line. Function at the value of 2 is equal to 7. So we don't need the big box where we're multiplying everything out. We can just have this. So that was our input, and this is our output. As another example, we could have f of x is equal to 4x plus 2. Now note that whatever letter we have here, so whatever letter we have here is what letter will be in our equation. And that's why when we substitute, we write. So if I wanted to substitute 5 into this equation, I would write f of 5, and that was equal to 4 times 5, because remember we're substituting in, plus 2. So 4 times 5 is 20, 20 plus 2 is 22. Now, not all of our functions have to start with f. We could have another letter. So another common one is g. So we could have g of x, and that's equal to, let's change it up, let's go for x squared plus 1. So if we said, oh, well, what is the value of minus 2? So what's g of minus 2? Well, we'd say, well, that's easy. We just substitute minus 2 into our equation. So we would then get minus 2. I'm just going to put this in brackets just to make it clear what we're doing. We're squaring that, and we're adding 1 to that. So minus 2 squared, well, minus times a minus is a positive, so that's 4, and it'd be 4 plus 1, and 4 plus 1 is, of course, 5. Again, we don't have to have f or g, we could have another letter, so we could have h. So we could have h of x, and that could be equal to x squared plus 4x. So if we wanted to find out what h of 10 was, for example, we'd just substitute 10 in place of x. So then we'd be left with 10 squared plus 4 times 10. 10 squared is, of course, 100. So we'd have 100 plus 40. 100 plus 40 is just obviously 140. So now we have an example, and it says, write t is equal to 2y plus 3 as a function, and work out the value of this function at y is equal to 4. Okay, so our equation that we have here is y is equal to 2y plus 3. Now, given what I said in the first parts of the video, when we have a function, we don't want the equation that we've got to look like this. We want something like f of something is equal to 2y plus 3. If we're going to use the letter f, it doesn't really matter. So if we use the letter f, we want f of something, and we want that to equal 2y plus 3. So what is the something? Well, the variable, or the letter in our equation is y. So that means that the of has to be y. So it's f of y is equal to 2y plus 3. So we've written that equation as a function. So that's done. Correct. So when it says work out the value of this function at y is equal to 4, well, it's just a case of substituting y is equal to 4. But how do we write that with our new function notation? Well, we say f of 4. So now the number goes in place of anywhere in the function that we had y previously. So that would be 2 times 4, and then adding 3 at the end. 2 times 4 is 8. So then we've got 8 plus 3. 8 plus 3, and that is equal to 11. So therefore, the value of our function at y equals 4 is 11. So that reads f of 4 is equal to 11. So here we have an exam style question. It says, given that f of x is equal to 2x plus 1 all over 3, calculate the value of f of 7. So from the question, we know that our function f of x is equal to 2x plus 1 all over 3. So we want f of 7. So it's just like what we've been doing. We have to substitute x equals 7 essentially into our equation. That's what this function notation means. So we're doing 2 times 7 plus 1, and that's all over 3. 2 times 7 is 14. So we've got 14 plus 1, and that's over 3. And that is, of course, 15 over 3. 15 divided by 3 is 5. So like that. So far, we've just substituted numbers into our functions. But we can also substitute letters and expressions into our functions. So in the first example here, we've got f of x is equal to x cubed plus 3x plus 1. And we want f of a. Well, if it was f of 2, we just substitute 2 in. So we do exactly the same thing, we just substitute a in. So we get a cubed, that's a really bad 3, a cubed plus 3a plus 1. We can't simplify that any further, so we'll leave the answer as it is. Moving on to this example here. H of x is equal to 4x squared plus 2x, and we want h of t. Well, it's the same thing, we'll just substitute t in. So we get 4t squared plus 2t, like that. So now we've got a slightly different example. We've got g of x is equal to x squared plus 1 all over 3. And we want to substitute the expression x plus 2. So we want g of x plus 2. Well, again, it's really easy. We just have to substitute x plus 2 where we see x, but we've got to be careful. So it will be x plus 2 all squared plus 1 over 3. Now we've just got to expand that bracket. So we'll have x plus 2, and then we've got that squared, so the bracket twice, x plus 2, then we're adding 1, and that's all over 3. So then expanding that bracket out, we'll get, and I'm just going to sort of do it quickly because I've kind of run out of room. So we've got x squared, and it's plus 2x plus 2x, so that will be plus 4x. And then we've got plus 2 times plus 2, well that's plus 4 plus 1, so that's plus 5. And that was all over 3. I do appreciate I've rushed over the expansion of that bracket slightly, but that's really not the point. I'm just trying to get you to understand what we do when we substitute into functions. But that is the answer. So do take your time with that expansion if you're working through this question, and see that the answer drops out. And then for this last one, t of z, well, again, all we've done is just substituted in. So we get z to the 4 plus 2 lots of z. So in summary, what have we done in those examples? Well, we've realised that we don't have to just substitute numbers. So we don't have to have f of 2 or h of 10 or whatever like we were doing before. We can substitute letters or expressions. And we're going to see some exam questions now where we're required to substitute letters and expressions into our functions. So this is just setting us up for those exam style questions. So we'll be moving on to those exam style questions next. Different question, and it says given that f of x is equal to x squared plus 3x minus 5, express f of 2x minus 1 in the form ax squared plus bx plus c. So we've got to substitute this in. So we've got f of x, and that is equal to x squared plus 3x minus 5, and we want f of 2x minus 1. What that means is we've got to substitute 2x minus 1 in place of the x's that we see. So that means for the x squared part we'll have 2x minus 1 all squared plus 3 times 2x minus 1 minus 5. Now we just have to simplify this, so we'll expand our double brackets. We've got 2x minus 1, and then we'll also have 2x minus 1. But we can deal with this bracket here as it's already written in a form we like, so that would be 6x minus 3, and then we're minusing 5 from the end. So now we'll expand our double bracket. So 2x times 2x, well that's 4x squared. Then 2x times minus 1, well that's minus 2x. Then we've got 2x times minus 1 again, so that's minus 2x. And then we've got minus 1 times minus 1, well that is of course plus 1. Then we've got plus 6x minus 3 minus 5. So all we need to do now is collect our like terms. We've got 4x squared at the front. There's no more x squareds. We've got minus 2x minus 2x. Well, that's minus 4x. Then we're adding 6x. So that'll be plus 2x. And then we've got 1 minus 3 minus 5. And that will be minus 7, I believe. Yeah, minus 7. That is now of the form ax squared plus bx plus c. So that's our answer. So what we've done there is we've substituted an algebraic expression into a function. The last exam style question, last example, in fact, that we'll do in this video, it says f of x is equal to x squared plus 2. So f of x, and that's equal to x squared plus 2. And then it says g of x, g of x is equal to x plus 14. Then it says find the values of such that, don't know what that a is doing there, f of a is equal to g of a. So it would make sense that we would have to work out what f of a is and what g of a is. So we'll do that. So f of a for this function, well that's going to be a squared plus 2, and then g of a is going to be equal to a plus 14. What have I done there? Well, I've done what I'd do if I had a number. I've just substituted a in place of the x's. So just like what we were doing before. Then it says find the values such that f of a is equal to g of a. So we've now got to equate these functions. So we'll have a squared plus 2, and that's now equal to a plus 14. But what can we do now? Well, I think a sensible step here would be to get everything on one side. So we can go a squared minus a plus 2 minus 14. And because I've moved all that across, that's now, of course, equal to 0. Now, it's kind of looking like we're going to get a quadratic here. And then when it says find the values, it's not just a value, it's the values, our quadratic alarm bell starts ringing and we should be thinking, I think we're going to get a few values here. And if it's quadratic, obviously, we know that we can get 2. So we're thinking that we should be getting 2 values here. How are we going to get these values? Well, if we tidy this up, we'll get a squared minus a plus 2 minus 14, well, that's minus 12. And now that looks like it's crying out to be factorised. A squared minus a minus 12. That looks like it wants to be factorised. So we'll factorise that. So I used a slightly different method of factorisation to what you may have seen. But if you factorise that the way that you know how, So I make it a plus 3 a minus 4, and that's all equal to 0. That's what I make it. So here, expand that out just to check. A squared plus 3a minus 4a, well that's minus a, and then plus 3 times minus, yep. So therefore, our values of a can equal minus 3 or a can equal positive 4. So those are the values. So we were finding the values such that this equation, where the two functions are equal at the point A, is true.